Hello everyone and welcome back to my channel. In my previous videos, we explored the fundamentals of non-circular gears, starting from mathematical theory, going through the concepts of evolute and involute, and then moving toward CAD modeling in SolidWorks. Many of you followed along as I explained elliptical, logarithmic, triangular, and square gears as well as other advanced forms. Today I am excited to share with you a new methodology that I have developed for generating non-circular gears. This approach builds on my earlier research, but introduces a more robust way to handle both convex and concave centrodes during the rolling process, resulting in generating any type of non-circular gear set accurately and according to the requirement of the machine needed, which is represented by the speed ratio variation. The flowchart appears on the screen describes the methodology. The core idea here is simulating the rolling of pinion cutter on the centrode and extracting the inflow. With my updated MATLAB code, the rolling simulation now guaranteed that the cutter produces accurate and realistic tooth profiles every time, even when concave sections are present on the centrodes. Let me show you some of the results. Here we are going to see several test cases generated by the program. Case 1, a smooth convex centrode. Let's enter the values of the constants A, B, and C of the speed ratio equation, as well as the other inputs, which are the module, standard pressure angle, and the cutter's number of teeth. Here we see the speed ratio variation, also the rolling simulation, which results with extraction of the envelope saved as DXF file for using in CAD software. Figure 2 shows the main curves, pitch curve of the centrode, the evolute of the centrode, the base curve, and the tip with the rod curves. Case 2, a centrode with mixed convex and concave sections. The resulted gear here is triangular 1. Case 3, a more complex sinusoidal variation. The resulted gear here is square 1. Case 4, circular gear generation. Let's see if this code software is also valid for circular gears generation. As we know, circular gears are a special case of non-circular ones, where the evolute of the centrode is the center of the circle. We give the value 0 to the constant B in the speed ratio equation, which means the speed ratio is constant. It's clear that the involute profiles of the teeth are identical, demonstrating the validity of my MATLAB code software for generating circular spur gears. Case 5, a more complex variation. We can notice the straight parts on the centrode. In each case, the software not only simulates the rolling of the pinion cutter but also extracts the final contact envelope as DXF file for further CAD modeling. This methodology opened the door to designing a wide variety of advanced non-circular gears with confidence, whether for academic research, machine design, or innovative machine systems. More efforts need to be made on the accuracy of the rolling simulation and the extraction of the inflow. This means increasing the number of points, maybe into millions, which need more powerful computer than mine. Finally, if you enjoyed this content and want to see more application of non-circular gear design, don't forget to like, subscribe, and share. And of course, feel free to leave your questions and thoughts in the comments below. Thank you for watching, and I will see you in the next video.